Lagrange's mean value theorem. What is Lagrange's mean value theorem? Let f of x is a real valued function in a closed interval a comma b which satisfies the following conditions. Condition number 1. F of x is continuous in a comma b. Condition number 2. F of x is differentiable in a comma b. If the given function f of x is a real valued function in closed interval a comma b are the limits. Let's suppose a is 1 and b is 3 here. If the f of x is a continuous function and if it is differentiable, then there is at least one point c belongs to a comma b such that f prime of c equals to f of b minus f of a over b minus a. It means that if I have a function f of x which is a real valued function in interval a comma b, where f of x is a continuous function and f of x is differentiable, then there is at least one point which is c belongs to a comma b. A comma b are the limits. The point c must be within this limit. The value of c should be between a and b, where point c can be calculated by this equation f prime of c equals to f of b minus f of a over b minus a. It is the equation of Lagrange's mean value theorem. Let me draw a graph. This is x-axis and here is y-axis. This is my point A and this is my point B. Here is the function f of x. This black curve is the function f of x, which is a real valued function in a closed interval a comma b. Let me connect these 2 points here. This is a slope. Name this P and Q. Let me connect point A with the y-axis to have f of a and connect point B with the y-axis to have f of b. If I draw different tangent lines on this curve and different points, there will be a point where the tangent line is parallel to the slope P of Q. The point where it touches the curve is point C. This is my point C. Let me connect it with the x-axis. So I can see here that C is in between A and B. Look at the right side of the equation f of b minus f of a over b minus a. It is actually the slope of P of Q. The slope of P of Q is y sub 2 minus y sub 1 or x sub 2 minus x sub 1. This y sub 2 is actually f of b. Y sub 1 is f of a. X sub 2 is b. X sub 1 is a. The left side of the equation f prime of c, I can find from here. Let me connect this point C with the y-axis to have f of c. This is my point C. That's how I got f prime of c. Now going back to the 2 conditions, where condition 1 says that the function f of x is continuous in a comma b. To understand this in graphical perspective, look at the graph of function f of x, which is the black curve. It's a continuous function between a and b. There is no discontinuity and there is no breakdown in this curve. Therefore, the function f of x is a continuous function. But if I break this curve here, look inside the circle, there is a breakdown in the curve. Now the function is no more a continuous function. It is a discontinuous function. The function has to be a continuous function. Look to condition number 2, which says that f of x must be able to be differentiated. Let's suppose that f of x equals to 2x squared plus x. Can I differentiate this function? Yes, I can differentiate it. Differentiation of 2x squared plus x equals to 4x plus 1. So it's able to be differentiated. The final summary of Lagrange's mean value theorem is that if I have a function f of x, which is a real valued function in a closed interval a comma b, where function f of x is continuous and f of x is differentiable, then there is at least one point, which is C, within the interval a comma b. The point C must be between a and b. It should be within that limit, where the point C will be calculated by this equation f prime of c equals to f of b minus f of a over b minus a, which is the equation of Lagrange's mean value theorem.